Hello guys, welcome back to my channel Data Science with Gagan. So first of all, yeah, a very happy new year to all of you guys who are watching this video, and may this year brings a lot of hello guys, welcome back to my channel Data Science with Gagan. And first of all, a very happy new year to all of you guys who are watching this video, and may this year brings a lot of opportunities in your career. So yeah, let's back to our agenda. As we ended up the last video with the conclusion that in the next video we will see if we can do object detection using transformers or LLM. So yes, we can do object detection using LLM or transformers, and the results are really very amazing. And you will be surprised after seeing the results because we are getting better results. So let's start with object detection using transformers LLM. Here in the screen you can see this is going to be the content for this video, where we will look around the DETR and it's working. Basically it stands for detection transformer, as we use transformer for the object detection purpose. And then we'll take up one pre-trained model of DETR and we'll do inferencing on it, as we did in the case of all YOLO models. And then we'll take up our custom data set and and also one pre-trained model and train that model on our custom data set, as we did in the case of YOLO model. And we'll take up that trained model and we'll do inferencing on it. Okay, so let's start with DETR. As I told, it stands for detection transformer, and basically it is a deep learning model where we use transformer to predict the bounding boxes and the class level of the object that we have seen in the image. Okay, and with the transformer, DETR can capture the global context and the relationships between the objects in an image that it has seen so far, and which leads to more accurate detections. And then DETR makes object detection a direct set prediction problem. Here, its goal is to consider all the objects in the image as a set and predict their bounding boxes and classes in a single pass. This new approach improves the detection accuracy, especially when many of. So let's start with its working, where we will see how it works. So basically, it is having three major components: backbone, transformer, and prediction heads, where it uses CNN network in its backbone. And this is the first component and backbone of DETR, where we feed the image to the CNN network, which takes the image and outputs the feature map for all the objects that it has captured so far in the image, right? And the main thing is that here we can have any CNN network, ResNet or VGG, right? Now let's come to transformer component. As we use the typical transformer here, which consists of both encoder and decoder. You can see in the image here, like, we have both encoder and decoder. But first we encode and then we pass the encoded information to the decoder to generate the things, right? So here, the output of the CNN component is flattened array, where flattened feature map, which is 1D feature map. So encoder takes the flattened feature map and encodes it. So one more thing before we feed this information to the transformer add positional embeddings to the feature map. And then encoder contains multi-headed self-attention blocks, so it tries to capture contextual information between different parts of the image. And then encoder gets to know about the relative position of all the objects through the positional embeddings, as we added all the positional embedding in the beginning. And then transformer decoder learns the relationship between the CNN encoded features and learnable object queries. Typically we require query key and value in the case of NLP, whereas DETR introduced the new term, which is object query, which refers to the learnable representation of objects the model need to predict. The number of object query is predetermined and remains fixed. The key denote the spatial location in the image, while the values contains the information about the features. Okay, so this is all about the transformer component. Now we have the third component, which is prediction head, The prediction heads output the bounding boxes and classes of the detected object. They consist of feed forward network head that either predict the bounding box and classes for the detected objects, or no object class for no detections. Okay. So furthermore, DETR employs the technique of bipartite matching to ensure that the predicted bounding boxes are associated with the ground truth objects, as we used NMS, right, in the other models. So similarly, it used the bipartite matching, and this method also refines the model training. Okay, so this is all about its working. So now let's jump to the inferencing part, where we will take up one pretend. So let's start with the inferencing part using the pre-trained model. So here in the screen, you can see these are all the libraries that I have imported, right? And majorly we will be needing transformer, so we can have the access to the DETR model from the Hugging Face. So before we move ahead, let me give you the brief about ResNet 50 model. So it's nothing else. Just the thing is, we will be using ResNet 50 model in the backbone, and rest of the model architecture will remain same. As I told in the working section, right? We can have a multiple kind of CNN networks like VGG16, ResNet. Now ResNet can have a multiple variants, and VGG also can have multiple variants, right? So we can have any of the model for feature extraction in the backbone. Okay, so that's what we are going to use here, ResNet 50. Okay, so if you want to read more about DETR ResNet 50, you can go, you can visit this website. I'll mention this website in the video description, and you can find it there. Okay, so let's start. So and also I have imported all other libraries which are required. So you can see, here we are just reading the image, where we have multiple persons moving around, and one verse in the background, right? And then using the so we will be using the same model for image pre-processing and object detection models, as you can see here. And also, whichever device is available in our system, if, whether it's CPU or GPU, we will use that to run the model. If CPU is there, then we will be using CPU. If GPU is there, then we will be using GPU to run the model. The advantage of using GPU over CPU is that we will be having inferencing speed high as compared to CPU. And once you will do this, you can see a summary of the model is there. Like this is basically, this is the architecture of ResNet 50 DETR that we are going to use. Okay. Okay. And like you can see here, we have read this image so far. Now let's do the inferencing or object detection on this image. So here you can see, like the model is able to detect all the objects, with the good accuracy, right? Even you can see, one person is there, like who is not completely in the image, but some part of its body is there in the image. But even we are able to detect that person with the 98% accuracy, right? So this is the power of object detection using transformers. That's what I told in the beginning of the image, right? The results were very amazing, and results are very amazing. You will be surprised after seeing them. And even you can. So till now we saw the inferencing on the image, where we were reading the image and pre-processing it, and then we were passing that pre-processed image to the model object detection model, and we were getting the results. And that's what we saw in the previous cell. Now let's come to the live video inferencing. So here what we will do, we will be using our web camera to get the live feed, and we'll feed that feed live feed to the object detection model, and then let's see how it predicts in the live feed. Okay, so here you can see, first I'm reading the image, I'm reading each frame one by one, and then I'm taking this its copy. And then then what I'm doing here, I'm passing that image to the preprocessor to preprocess it. And then once I'll preprocess it, I'll be passed that output to the model. Once I'll be get the output from the model, what I'm doing, I'm just reading all the detections from the output. Here you can see, and also you can see like what I want all the detections which is having more than zero point 0.9 confidence score. If you want, then you can decrease it, but like it's on you, like it completely relies on your condition, on your requirements. Okay, once I'll be having all these things, then I'm annotating it here, and I'm getting all the labels here. Once I'll do it here, once I'll draw all the things on the frame, whatever detections I got, labels I got. Once I'll do all these things, I can visualize all the things using cv2.im show. That's what I'm doing here. So now let's have a look at its result. So yes, so here you can see it's detecting me as person with good confidence score, and also it is able to identify the couch which is there behind me with good confidence score. So I have taken these objects in my hand, remote and bottle, and it's able to identify both things with good confidence score, 100, 97 and all. Okay, and it's good, right? Let me take one other object as well. Here it's a diary. Let's see how it what is it's identifying. Okay, it's identifying this diary as laptop because somewhere it's looking like a laptop like, so that's why it's identifying this diary as laptop. Now what I will do, I will rotate my camera to identify the household things. And so yes, I have rotated my camera, and the result you can see it's able to identify some plants out there in the balcony, and also it's able to identify TV, but it's fluctuating because of that confidence score, right? If I reduce that, you can see the consistent bounding box around the TV and also around the objects, right? So the results are quite good, right? So this is how the DETR object DET. So now we are done with the inferencing part using pre-trained model. Now what we will do, we will train our model on our custom data set. So for training purpose, we will be using the notebook which is there from the RoboFlow side. So here they have mentioned everything, how to train the DETR model on our custom data set. So let's start with this. So first what we are doing, first we are checking if NVIDIA SMI, so we are using this command to check if CUDA is there. If it is there, then what version we are using. So here you can see like this is for the Colab. If you want to run this notebook on your local machine, then you can. If your system is not allowing to use GPU, then you can use Google Colab. So that's what I'm doing here. For my purpose, I used Google Colab for training purpose, and then I downloaded this file into my local machine. No worries, I will also share this file with you guys. Okay, first you can see, first I'm checking the CUDA version, and then I'm importing all the necessary libraries as we did in the upper section. Okay, so that's what. And also main thing is we are going to use PyTorch lightning to train the model. Okay, so first what we will do, first we have loaded the model from the Hugging Face, and then we have done some prediction using that, even then inference plus NMS, which is non-max suppression. So if there are multiple boxes around the object, then we will be having only one using NMS. And then we are going to use then we are going to use this data set which is of football. Okay, so let me show you. Here it's loading. Okay, so where we will be having players, referee, football, goalkeeper. Okay, the model will detect who is the goalkeeper, who is the player, and who is the referee in the ground. Okay, so this you can find this data set as well inside this notebook. Okay, and okay, okay, and then what you can do, how we did the object detection, or how we did the annotation part in the previous videos for YOLO, right? So same thing is there, but this is already available, so we don't need to do annotation again. So how we export the data set in the previous video, so same things we are going to do in the same in the current video. Same, we will be using same Python code to extract the data set into a local machine. Okay, and then we have this class to prepare our data set for training and validation purpose. Once we will prepare the once we will prepare all three data sets, then we can go to the next part. So here you can see it is just for the visualization purpose, right? How, like, how, what kind of annotations we have done so far, right? And then here we have written this class DETR, which is for the training purpose. We are going to use this class to train the model on our custom data set. So here, like, on this is the command, and as I told, right, we are going to use PyTorch Lightning for training purpose. So for from this we are importing trainer to train this model, and these are the parameter that we have given here. Devices one means which is GPU, then accelerator GPU, then how many epochs we want, and then we have log every and steps, like, because we are logging all the things in the local machine, right? So at what step we want to log all the details. So we have mentioned 5 here. So once you will run this shell, you can see the folders are getting created in your directory for that particular model. Once the model training will done, you can see a model, you can see the folder in your directory, and all the configurations will be there. Okay, once if you are doing it on the Google Colab, then what you can do, you can download that pretend you can download those model that you have trained so far on your local machine, and then you can use that model on your local machine. Okay, so that's what I have done in my case, post training model on Google Colab using the same notebook, and then I have downloaded that model in my local machine, and then I'm using it here. So here you can see custom model, which I had trained on Google Colab, and then now I'm using it for the inferencing part. So this is how we have trained a model. Now let's see how it's detecting. So let me show you one thing before we start. Okay, so this is the video where, like, which is related to football, because we have trained this model on the football data set. So let's see whether the model is able to identify all the players, balls, and referee in the video or not. Okay, so we will feed this video to the model, and then let's see how it works. Okay, it might take some time, and also you can see I have reduced this threshold to 0.7 because I want a consistent box around the objects, because if I'll increase this, then it might fluctuate. Okay, taking time. Here you can see, right, player. If I'll reduce this threshold, right, so it might be able to identify this ball. Let's try. Okay, okay, I have renamed this window as YOLO. Let take it as DETR. Let's keep it as 0.5. Okay, now let's try. Now you can see we have referee there, right? So it's able to identify that referee as well. Okay, identify ball. Yep. See, if I reduce this threshold to 0.5, then it's able to identify ball, and the results are quite good, right? And which is similar to the YOLO models. So that's what we can do using transformer as well. So this is all about this video, where we learned about the DETR model, which is detection transformer, where we use transformer for the object detection model, and where we learned about its architecture, and then we'll have a then and also we had a look around its inferencing, right? Yeah. So see you guys in the next video. Most probably we will see something apart from the computer vision.
To keep me motivated for more videos on data science projects, please do like and subscribe. And please do not forget to press bell icon for notification of new projects videos.